Hey guys, here we're going to talk about calculating missing measurements of similar figures, okay? So let's do a little review about what similar figures actually are. So there's two characteristics when you talk about similar figures, okay? So the first one is that they have to be the same shape. If they are not the same shape, then it's obvious that they're not similar figures, okay? But if you can see that they are the same shape, then you want to go ahead and take a look at the second characteristic, okay? Which is going to be that the ratio of their corresponding sides must form a proportion. Okay? In other words, the ratio of their corresponding sides are equal. And I'm going to show you an example of what that looks like, okay? So here goes our example. So here we have two triangles, okay? Triangle A and triangle B. So our triangle A, our short side is 2, our long side here is 5, and B is 4 and 10. All right, so the question is, are these similar figures? Well, in order to figure it out, first of all, we check, is it the same shape? Well, yeah, they're both triangles. But specifically, these are right angle triangles that I'm drawing, okay, so you know that they're the same. Now, sometimes there are similar, or triangles may look the same, but they might not necessarily be the same. How would I know? Well, I need to check the second characteristic because both of these must be true for these to be similar, okay? So I know the first, they are the same. They are both triangles. Now let's check the ratio of their corresponding sides. What do I mean by ratio? What do I mean by corresponding sides? Well, what I'm asking is the ratio of the long side of A to the short side of A, is that equal to the long side of B, the ratio of the long side of B and the short side of B? So now that we're here, let's go ahead and put the numbers in, the measurements that they actually gave you for these different sides of our triangles, okay? So the long side of A is given as 5 units, okay? So that's 5 divided by the short side of A, which is 2. That's our ratio, 5 halves, okay? It should be equal to the long side of B, which is 10, and the short side of B is 4. Now, when we talk about corresponding sides, just take a note or notice that the 5 at the top of our fraction on the left and the 10 on the top of our fraction on the right, these are both the long sides, okay? And then on the bottom, you see both the short sides. So basically, when you talk about corresponding, we're talking about the sides that are in the same relative position here. All right, so now let's go ahead and simplify, okay? And let's see if our fractions of our ratios form a proportion. Well, there's a number of ways you can go about doing this, okay? So one way you can do it, you have 5 halves should be equal to 10 over 4. One thing you can do is you can compare the fractions. You can look at the 5 halves, okay, and ask yourself, can that be simplified any further? Well, there is not a common denominator other than one, a common factor, other than one that can go into both 5 and 2. So that is as simple as it's going to get. And then you can go ahead and look at the second ratio, 10/4, and ask yourself, hey, can this be simplified any further? Well, there is a common factor between 10 and 4. What is that common factor? Well, that common factor is 2. So if I divide both numerator and denominator by 2, I will end up simplifying my fraction, or my fraction will be simplified to 5 over 2, 5 halves. So then what we notice therefore is that the left-hand part of my fraction and the right-hand part of my fraction become the same. They're equal. Okay, that's one way you can do it. The other way you can figure this out is you can go ahead and put your fractions down, your ratios down, because you know ratios can be written as fractions. They are fractions. Is equal to 10/4. And here we can implement a method called cross multiplication. Whenever you see something in this format here where you have a fraction being equal to another fraction, you can cross multiply. What does that mean? Well, we want to keep our equal sign, and what we're going to do is we're going to multiply the diagonals. So the first diagonal would be 10 times 2. You know that parentheses indicate multiplication. And the equal sign remains the same. It should be equal. So the product of the diagonals are equal when we talk about cross multiplication. And then we have 5 times 4, our second diagonal. So 5 times 4. Okay? Perhaps if I did it in different colors, it would be a little bit more, you can see it a little bit better. So here we go. All right, so now let's go ahead and look at what those products actually are. 10 times 2 is 20. And that is equal to 5 times 4, which is also 20. It should be, right? Is 20 equal to 20? Well, yeah, it is. So this is another method, and this is the method that we're going to be using, the cross multiplication method, when it comes to calculating missing measurements of similar figures. So let's keep going, and we're going to practice this a little bit, okay? All right, so we have here two triangles, and we are told from the get-go that they are similar, okay? So once you're told that they're similar, we need to go right ahead and look at the ratio of their corresponding sides. That language is important, okay? So we are given two side measurements. We're given the long side of both, well, we're given the long side. We know that that measurement is present, and we're given the short sides, okay? So those are our corresponding sides. So we have the long side of triangle A, the ratio is, and then the short side of A is equal to the long side of B, the ratio of the long side of B to the short side of B. And we're just going to plug in the values that were given for those sides. So what's the long side of A? Well, the long side of A is 25. And the short side of A is 10. And that ratio is going to be equal to the same ratio as the long side of B, which is given as x divided by or over the short side of B, which is 2. So now we have the format we're looking for. We have a fraction on either side of an equal sign. We have nothing else there. So we can go ahead and cross multiply. We keep our equal sign. And what we're saying is the product of the diagonals are equal, okay? So let's do that with a different color. 10 times x is going to be 10x. Okay, and that goes there. And then the product of this is equal to the product of the second diagonal, which goes here, which is 25 times 2. Okay, so let's go ahead and combine or simplify. 10x just stays the same. 25 times 2 is 50, right? And now our goal, we're trying to solve for x, that missing side. So the 10 is in the way. What operation is happening between the 10 and the x? It is multiplication. So the opposite of multiplication is division by whatever it is we're trying to get rid of, okay, which is the 10. So divide by 10. Whatever we do on one side, we must do on the other side, okay? So 10 divided by 10 is 1, so we're left with x on the left-hand side. And 50 divided by 10 is 5. So our missing length is 5 inches or 5 units, okay? Now you can compare your triangles to see if that makes sense. Or you can simply, well, let's go ahead and compare our triangles. That works, okay? So when we compare our triangles, if x is 5, right? To get from 5 to 25, from 5 to 25, we had to multiply by 5. 5 5s are 25. To get from 2 to 10, what do we have to multiply by? Well, we had to multiply by 5. That's a way you can do it as well. Now, what you're noticing is that the scale factor, which you're increasing by or diminishing by, is the same for all of the sides of our triangles, which is by 5. So let's go ahead and look at another example. In this example, we have two rectangles, and we're going to do the same thing we did in the previous example. We're going to do the ratio of the corresponding sides. So here we go. The ratio of our long side to short side, that's what we're going to work with for the first figure. So the long side is 14 and the short side is 5. That is equal to the ratio of the corresponding sides in the big figure. The long side, which is 42, to the short side, which is x. Okay? So our long side is 42 and our short side is x. Now, we're going to go ahead and do our method cross multiplication. We have two fractions that are equal to one another, and that's when we can apply our cross multiplication. Now, I want to make sure you understand that if I have like a plus some number here, I cannot do cross multiplication in the same way. I can only do it because I have specifically one fraction that is equal to another fraction. Okay, so you're going to keep your equal sign, that stays the same, and the product of your diagonals are equal. So my first diagonal is 42 times 5, and that is equal to my second diagonal, which is 14 times x, which is simply 14x. Now 42 times 5 can be simplified a little bit more, and that's going to be 210 is equal to 14x. And now we still want to get our x by itself, because remember, we're trying to solve for the missing measurement. So we're going to divide by the 14, because we're trying to get rid of it from the right-hand side. Whatever we do on the right, we just must do on the left. And so we end up with x on the right-hand side is equal to 210 divided by 14, which is 15, okay? And this is the same thing as saying x is equal to 15. And you can go ahead and compare, like we did the last time, to see if the scale factor is the same. Are we multiplying by the same number to increase our figure from one to the other? Or are we dividing by the same number to go from one figure to the other? Let's look at one last example. So here we are, and we are told that these are similar figures. Now remember, and this is a common mistake of a lot of students, we said that there's two things you want to look at when it comes to this idea of similar figures. One is the fact that they have to be the same shape. Are these the same shape? The reality is they're both rectangles. They are the same shape. They're just different orientations. In other words, one of our triangles is sitting on its long side, and the other one is sitting on its short side. So when we talk about corresponding sides, you want to make sure that your corresponding sides are actually matching, okay? So, in other words, if we're talking about the long side of A over the short side of A has to be the same as the long side of B over the short side of B, then you want to make sure that you are choosing the right measurements for the right sides, okay? So let's look at the long side of A. The long side of A is 7, and the short side of A is 3. That ratio must be equal to the long side of B. The long side of B is x. It is x, okay? And the short side of B is 12. Now, we can go ahead, look at what you have. You have two fractions that are equal to one another. So we can apply our cross multiplication. You're going to keep your equal sign, once again, and the product of your diagonals. So you have 3 times x, that's your first diagonal, or first product. And that's going to be equal to the product of the second diagonal, 7 times 12. Now, maybe you might be asking, do I have to do 3x on the left and the other one on the right? No. Once you have the correct products and the correct pairing of your numbers in your diagonal, then you can put it on either side, okay? So now we can go ahead and simplify this as much as we possibly can. So 3x stays the same for now, but the 12 times 7 can be changed to 84 because 12 sevens are 84. Next, we want to, of course, solve for x, our unknown side. So we divide by 3 on both sides because we're trying to get rid of it. And we end up with 3 divided by 3 is 1. 1 times x is x, and that is equal to 84 divided by 3, which is 28. So our missing measurement is 28.